I want to do another example of integration where trigonometric substitution is going to be necessary. Let's just talk first of all y. It's a fraction, so initially you should maybe think of substitution. If I made u 16x squared minus 1, du would be 32x. I don't have an x to do any substitution with, so substitution is out. Next, you start thinking partial fractions. Well, partial fractions is not going to work because of the square root. If the square root weren't there, we actually could factor this, but it's not going to work. So we go to trig substitution. I'm going to start by drawing my triangle. And we're trying to, again, mimic Pythagorean theorem. Since there's a subtraction here, I'm going to put a 4x on the hypotenuse. And I'm going to put a 1 right here. Now, this is the first time I haven't used the opposite side. Remember, we always try and make the opposite x whenever possible. It isn't possible in this case because the piece with the x, 16x squared, is the hypotenuse. Okay, this is a little bit different. Now, the thing about this one is the most common cases that we encounter in trig substitution, or the ones we like to use, are sine, inverse tangent, and inverse secant. And that's why I've chosen to use the adjacent, because adjacent over hypotenuse is cosine, so there really wouldn't be a difference. You could absolutely use cosecant. I'm using kind of the most common ones here. So this side, remember, is going to be 4x squared minus 1 squared, and then the square root. Okay, so kind of a sideways writing, but we have now perfectly mimicked Pythagorean theorem. Okay, so I'm going to put a theta right here, and let's list the things we know. Well, as I said, we're using secant. So the secant of theta, remember, cosine would be adjacent over hypotenuse, so this will be hypotenuse over adjacent. So that means that x is equal to 1/4 secant theta. So that means that dx is 1/4. Now the derivative of secant is secant theta multiplied by tangent theta. And we always like to list that then theta is the inverse secant of 4x. Okay, so we've kind of created this whole little table of things we now know. Now I'm going to start rewriting my integral. Okay, so I'm going to rewrite this as 1 over the square root of 16 multiplied by what x is equivalent to, so 1/4 secant theta squared minus 1 multiplied by dx. I should have had a d theta down here, apologize, which is 1/4 secant theta tangent theta d theta. I'm going to bring that 1/4 out front. I'm going to bring the secant theta tangent theta up top. Well, I'm going to square that 1/4 secant squared, so it becomes 1/16 secant squared theta. Well, 16 times 1/16. Let's go on. Bringing in my little table of trig things to know. Secant squared theta minus 1 is tangent squared. So I've got 1/4 the integral of secant theta tangent theta over the square root of tangent squared theta. Well, the square root of tangent squared is tangent. So 1/4 the integral of secant theta tangent theta over tangent theta d theta. Tangents divide out. So we're integrating secant. Now this is not an integral that you need to memorize. It is one you've seen before. You saw it in Calc 1. But as I said, you don't need to memorize it. So I'm going to tell you what it is. The antiderivative of secant is the natural log of secant theta plus tangent theta. It's something that you needed substitution to solve. Okay, and of course we have the 1/4 out front. Now, I'm going to slide this out of my way because we, of course, started with x's. We should end with x's. So we got 1/4, the natural log. Now, secant, remember, is hypotenuse over adjacent. So for us, that was 4x over 1. I guess I have it right here as well. So I'm going to replace secant theta with 4x plus, now the tangent I don't have listed in my things, but remember tangent is opposite over hypotenuse, or I'm sorry, opposite over adjacent. So I can do that. And over adjacent, which is 1, plus c, and this is our integral.